Hello, everybody. This is Chris from the Great Brick Lab, and we are here on week 3 for Big Robot. This is going to be a show and tell. Again, I am Chris from Great Brick Lab. This is Amanda, our main designer. Say hello, Amanda.
Hello.
What is Big Robot? You may be asking. So thanks for tuning in to this video. Big Robot is an artificial intelligence controlled Lego sorting robot. On the scroll at the bottom, you can see where you can give to this effort. On GiveSendGo/Lego AI. That donation, if you do give, will be given to the design of this and to the intelligence that controls it. Nothing in that giving will be used to the manufacturing of our robot. Why are we doing this? Because we think that the Lego that's in the world deserves to be sorted, and that's what we want to do with all of this effort. So today, like I said, is a show and tell. I think Amanda is just about ready to start showing us what she's built this week. So you ready to go?
Yeah, sure. Let me switch my camera.
You bet. So I'm going to kind of walk us through it. So show us what the belt looks like, or where the belt is. Or you want to start with the V channel? Is that what you want to start?
we can actually start with the V channel since that's where the parts go first.
Right. Okay. So talk to me about that.
So we created this giant V channel, inspired by some of the Lego sorting robots that we've seen before. The idea is that I will have a motor mounted onto this bracket, and it vibrates the entire frame, and this causes this flexible steel channel to vibrate, and the parts actually move down the channel. Why do we have this channel? Because the shape of it will cause parts that are stacked on top of each other to fall off of each other, and eventually out at the far end, on the other side, you should be seeing one part come off at a time. And this is important because our artificial intelligence will only be able to determine the type of part it is if it only sees one. So you got to make sure that the big pile of parts is reduced down to just one.
Mm-hmm. So then after the V channel, what happens next?
All right, so after the V channel, I'm building a spinning carousel, I call it. It's basically just a disc, and it will be mounted on top of this frame here. And in the middle of the frame, I'm going to have a motor that drives the disc, so that when the parts are going to fall onto the disc, and the disc will spin around, and as it spins, the parts will be drawn to the outside of the disc, so that they can be redirected around to the conveyor belt on the other side. And this way, our machine doesn't have to be as long as the V channel plus the length of the conveyor, because that would be not very space efficient. So instead, the parts will be turned around, and also this should help if there are any like side-by-side parts trying to get off onto the conveyor.
Okay, cool. All right, so it goes on the carousel from the V channel, then it's on to the belt.
Yeah, so the belt is going to be mounted onto this large MDF frame that I built. This frame is made out of, we have L brackets underneath of there that you can see, kind of like that. And we also have, each of the rollers has a plate, so this shaft is glued onto this plate, and it's mounted onto a slot so that when I put my belt on, I can actually slide the piece backwards and forwards to adjust the tension. So that way, if I make my belt just a little bit too tight, then I'll be able to pull it in, or if it's too loose, I can pull it out.
Yeah, and we're not talking about a high-speed belt here. How fast do you think it's going to go?
No. So this belt is going to, let me see if I can remember all of my numbers. we were expecting to sort one part every second. So I believe it's going to move the parts, whatever this distance is. I think it's like 3 inches every second.
Okay.
So it's not too fast. Whatever that means to you. It's just like this far in a second, which is, But we chose this is a 117 RPM motor, which is pretty slow considering how fast these motors are. So that's why this gearbox here is so big. And it's also hard to back drive. So yeah, it's not a high speed belt. We shouldn't expect to have any like whipping or anything.
Okay. All right. And then when it's on the belt, how does the Lego move down the belt?
So the Legos will be moved down the belt by these cleats. This is just a test piece I've created to see how well super glue works on the backside of this treadmill belt that we're planning to use. And I found that with a clean piece of poster board foam, I could get a pretty good tight glue joint there, and this does not want to come off no matter what. It is super firm, so I'll just be gluing these evenly spaced across the belt, and that will maintain the spacing between the pieces.
All right. How many of those cleats do you have to glue on there?
So based on the spacing of these holes, I'm going to need 50 total cleats.
Wow. Lots of cleats. That'll be a lot of manual labor there. So, okay. So so the Lego goes down the V channel, separates a little bit there. Then it gets down to an individual piece on the carousel. Then it drops onto the belt into a V channel. What happens next?
After it's on the belt, the motor back here, you can see this plastic piece on the back that covers an encoder. So the encoder measures how many rotations the motor has made. And so what the AI will be doing is we'll have a camera back at the beginning of the belt, and it will take a picture of the part, and it will identify which part it is and tell the computer program how far it needs to go before it runs the air to knock that part off.
So where's the air coming from?
So the air, we're going to be using an air compressor, and then the air will run into an input slot on the solenoid valve manifold. It's one of these two holes, and then using the program, we can control which one of these solenoids opens the valve, and the air will come out depending on which of the valves is open, and it will just there will be a hose running from this to this, and the hose will have a little nozzle on it, and the nozzle will like reduce the diameter of the inside diameter of the hose so that a little blast of air comes out here and knocks the part off into the bin.
Into a gutter that draws to a bin. Excellent.
Yes.
Excellent. So did we miss anything on what happens with the Lego on the robot?
I do not believe so. That will be all of the steps.
All right. Very cool. All right. So that's a great day. So that was what we're doing today. Today was the show and tell. So we are coming up to a point where we need to start doing some additional manufacturing. So a lot of the manufacturing is done. We need wiring to be done. Those parts are actually on delay, so those are coming. But we're hoping, this is week 3. We're hoping by the end of week 6, we will have the circuit board wired and everything able to run the solenoids, the motors, and everything will be running them. But between then, so next week 4 and the 2 weeks after that 5 and 6, we need time. We need to take the time in those weeks to program the artificial intelligence to actually get the program running and actually collect some data. So we have somebody working CAD Bunny is working on making some data for us, but we do not have a program. We have no program at this point. So my goal is to get into the Discord and get a group of us together that have been working in the AI channel. If you want to join that, the link is in the, it'll be in the description of this video, but it's also in the scroll right now as well. And I'm not going to try and say the letters in that link. Just go to the link inside the description. So the next 3 weeks, we really need to kick up the aggressiveness on developing the program. So that's going to be our goal coming up here. So we have circuit board by the end of 6 weeks. What we think with if we can get an AI a program running and we can get some data and we can get the parts moving across the belt, we think that we'll be able to actually show the machine working in some way by week 7, possibly week 8 on a 12-week project. We have 12 weeks to finish this. Isn't that right? If I remember correctly.
So the grand total for my summer was 14.
14. So, and I think I cut it down to 12 just to give us an extra buffer of those 2 weeks, just in case something came up. So cool. I think that covers it for today. Do you have any closing comments, Amanda?
No. So I guess one thing that I do want to mention is with the AI. I can't remember if I mentioned this last week, but we're not looking for somebody who just knows everything about AI. That's not entirely necessary. It's just we need someone who has time to try out the tools that are available and tell us some of the pros and cons, or maybe like how they work, what kinds of things we need in order to train it, what kind of data might not work, that kind of stuff. So
right. And if you go back to week 2's video, we had a lengthy conversation about the kind of things we were thinking about for AI. We had TensorFlow, and we were also thinking about Teachable machine. We really haven't landed on a specific one yet. So like Amanda said, if you're just willing to give us some of your time, invest some research into helping us discover what would work, just get involved with the conversation. The place to do that is on the Discord channel. And if you're already a member of the Discord and you want to step up as to become the team leader for the AI, please reach out to me. I am seriously looking for that. And mostly we just need somebody's time to help us to get that ball rolling a little bit. All right, cool. So that's our update for today. Again, the Give Send Go link, givesendgo.com/Lego AI is a way for you to help contribute to us at the end of this project, giving this design away. She will give, Amanda has done all the work for the CAD design on-site. Is that right? On-site?
On Shape.
On Shape. Thank you. So on Shape, and that's a place where she can get design for free, but then also give that design away to the world. And then once we develop the AI as well, that will also be open source. So the money that comes into that Give Send Go will be used for that and not for the manufacturing of the machine at all. All the costs for the machine that she's been manufacturing has been coming out of the Great Brick Labs budget. So if you want to give, that's great. If not, if you just want to contribute in the Discord, that's also wonderful. We are doing this as a kind of a crowd sourced and funded and community build. So that's the goal.
Yep.
All right. Very good. So thank you for your time tonight, Amanda.
Thank you for having me.
Yeah. And it looks excellent, by the way. I'm very impressed. I did a quick short on the channel. If you want to see the V channel actually working, she had the motor on it and she was so excited. She sent me a quick video. It's actually very cool. It only takes a few seconds to watch, and you can actually see the V channel when about the minute she finished making it and got the motor attached. She probably sent that video to me, I'm pretty sure. So, all right. Well, we're going to end this one here, and we'll see you all again next week.
Yep. Everybody have a good weekend.
Bye.